We're ready now to try and get a snapshot of what our atmosphere looks like. And we're going to do this in two ways. The first, we're going to look at the density and the pressure of our atmosphere. And the second way, we'll look at the temperature. We're going to start off by looking at the density of our atmosphere. So in this video, we're going to talk about density and buoyancy. Now, the atmosphere is thickest near the surface and gets thinner the higher you go. You've probably heard of mountain climbers who have to take oxygen with them because the higher they go, the thinner the atmosphere is. Why is this? Well, to understand, we need to learn a few principles of physics. The first is weight. Another name for weight is the force of gravity. No matter what's here around the Earth or even out in space around the Earth, there is a gravitational attraction between these two objects, drawing them closer and closer together. Now, we can easily calculate the weight of an object by taking the object's mass, how much matter is in that object, and multiply it by the acceleration of gravity. In other words, if you were to just drop it, how quickly would the speed increase? Now, here close to the surface of the Earth, if you were to drop, say, a penny off of a building, then its speed would increase by 9.8 meters per second every second. So if you just drop it 1 second later, it will be traveling at 9.8 meters per second. Another second later, it will be going twice that speed at 19.6 meters per second, and so on. Every second that passes, it will speed up by 9.8 meters per second. And that's what this G variable is that you see on the slide here, 9.8 meters per second every second. So that's meters per second squared. So how do you calculate an object's weight? Just take its mass and multiply it by 9.8. Very important note, though, you have to have the mass in kilograms. Okay. A couple videos ago when we talked about units, I told you there was a difference between kilograms and newtons. This is the difference here. Kilograms measures the mass, whereas the newton measures weight. You say, oh, okay, sure, whatever. What's the difference? Well, let's put it this way. Here on Earth, you are made of a certain amount of matter. That's your mass. And you have a certain weight. Very related. Okay, and we can work with both of those together. But if you go to the moon, your mass does not change. You're still made up of the same amount of matter, but the acceleration of gravity changes, so your weight changes. Okay, so there is a very important difference between mass and weight. All right, so here's a quick example. The mass of a given person is 65 kilograms. What is this person's weight? So the weight is calculated as mass times gravity. So we're just going to multiply the mass of 65 kilograms by acceleration of 9.8. Multiplying those together, you get 637 newtons. Now, we want, if you want to have a understand what that would be in pounds, that's about 143 pounds. Okay, and again, you can go back and use the principles of unit conversion I taught you a couple videos ago to get that. Essentially, 4.45 newtons is equal to 1 pound. We want 1 pound, so leave that on top. We divide by the current unit of 4.45. It's 637 times 1 divided by 4.45. Again, go back to the units video if you have any questions on that one. Now, here's the thing. Gravity works on us. It pulls us down, keeps us on the surface of the Earth. It also pulls down all the gases that are up there in the atmosphere. Yes, they're up there, they're floating, but gravity is still pulling them down, and that keeps the atmosphere around the Earth. If it weren't for gravity, the atmosphere would have disappeared a long time ago. Okay, so gravity is what keeps the atmosphere close to the Earth. In fact, the it pulls the gases so that they are, let me see if I can get a laser pointer here. Well, here, we'll do this. I apologize. Sorry, I got to get rid of a couple things there. You should be able to see my mouse here. Gravity pulls many of these gases towards the surface so that only the lighter weight gases stay on top. So it's very, very concentrated close to the ground because gravity is trying to pull it all downward. And so now, in order to understand that a little bit better, we need to talk about density. Density is a measure of how thick the air is. Basically, we take the mass, how much matter is there, and divide it by the volume it takes. So, for example, you have 4 cubic meters of water, has a mass of 4,000 kilograms. What's the density? Well, you take the mass of 4,000 kilograms, divide it by the volume, 4 cubic meters, and you get that the density of water is 1,000 kilograms per cubic meter. Basically, it's just saying that if you have 1 cubic meter of that substance, it would have a mass of 1,000 kilograms. That's pretty much what the density is saying. If a particular gas has a density of 1.7 grams per cubic centimeter, then it means that if you have 1 cubic centimeter of that gas, it would have a mass of 1.7 grams. Okay? Now, since most of the air is being pulled down to the surface, you're going to have a lot of molecules crammed into a smaller space. So you have a certain amount of mass crammed into a small volume. And when you divide by a small volume, you're going to end up with a high density. Whereas higher in the atmosphere, the same number of molecules will be more spread out. So you have the same mass, but in a smaller volume, a larger volume. And when you divide by a larger volume, you end up with a lower density. Okay, so why is this important? Well, this leads perfectly into the concept of buoyancy. Buoyancy is what makes something float or sink. Well, let me correct myself. Buoyancy itself doesn't make you float or sink. It's the balance between buoyancy and weight. Okay, let's take these 2 canisters you see here. They both have the same volume. Buoyancy depends on volume. Okay? The buoyancy is determined by the amount of volume that is the amount of fluid that is displaced by the object. Okay? So you have 2 objects that have the same volume. The green one on the left has a low density. That means it has very small mass in this given volume. The one on the right, that's red, has a high density. That means it has a lot of mass in this given volume. Since they have the same volume, they're going to have the same buoyant force. But because the high density cylinder has more mass, it's going to have a larger weight. The low density cylinder has less mass, so it'll have less weight. And as you can see from the arrows, the low density cylinder has a larger buoyant force and a smaller weight. Since the buoyant force is more, that's going to cause that cylinder to rise. But the high density cylinder, since there's more mass and more weight, that weight is larger than the buoyant force, it's going to sink. All right, let me sum that up this way. The buoyant force is determined by the volume of the object. Okay, so if you have 2 objects of the same volume, they're going to have the same buoyant force. If the buoyant force is stronger than the weight, which depends on the mass, then it will float. But if the buoyant force is smaller than the weight, then gravity will pull harder and the object sinks. And this is the story with our atmosphere. Let me just go back to this slide here. We have some fairly dense molecules in our atmosphere, larger amounts of mass, water and carbon dioxide and oxygen. are all more massive, so they are going to have a larger weight than a buoyant force. So they're going to sink towards the bottom of our atmosphere. But the lighter weight atoms and molecules like hydrogen and helium, they're going to have a smaller weight, so the buoyant force takes over and they float. There you go. And as a result, you get this profile of the atmosphere where you have very low density at higher altitudes. And then as you get closer and closer to the surface, your density is going to increase. And so you end up having a much higher density near the surface. High density near the surface, lower density as you go up. In our next video, we'll look at this purple line, which is air pressure, very much related to the weight that we have been talking about.